Hi everyone! Today, we're diving into a project that combines the power of the W5100S-EVB-Pico2 with Adafruit IO and MQTT to create a smart LED control system. Adafruit IO is a cloud service that simplifies IoT project data storage and visualization. MQTT, or Message Queuing Telemetry Transport, is a lightweight messaging protocol ideal for connected devices. Together, they make real-time communication in IoT applications seamless. So, let's see how they all work together. These are the components that we need to use in this project. The RP2350 microcontroller board, W5100S-EVB-Pico2, is an excellent choice for IoT projects. It features dual Cortex-M 33 cores for efficient processing, along with 520 kilobytes of SRAM and a C-type USB port for easy power and data connections. With 48 versatile I/O pins and built-in Ethernet support, it allows seamless integration of various sensors. This board can be used for applications like smart home devices, environmental monitoring, and wearable health trackers. Before starting, ensure you install the necessary libraries and refer to the schematic for proper connections. To download and install CircuitPython, first visit the CircuitPython website, navigate to the Downloads section, and select the firmware for your board. After downloading, connect your board to your computer while holding the bootcell button to enter bootloader mode, which will make a new drive appear. Transfer the downloaded CircuitPython firmware file to this drive. Next, download the necessary library bundle from the CircuitPython Libraries page. Extract it and copy relevant libraries, like Adafruit WizNet 5K and Neopixel, into the lib folder on the CircuitPy drive. The circuit diagram is shown. We'll use GPIO0 for the LED output to control its state. Since only GPIO pins 26 to 28 support analog input, we'll use GPIO26 for the switch input to read the analog signal. Finally, connect the Ethernet to access the Adafruit IO interface, enabling remote monitoring and control of our setup. When connecting wires for the component, start by identifying all components and sensors you'll use. Then check the schematic for correct pin assignments. Connect the circuit according to the diagram provided, ensuring each connection is secure and accurate. After double-checking all connections, power on the board for any issues. MQTT is a lightweight messaging protocol optimized for low bandwidth and high latency networks, making it ideal for IoT applications. Its advantages include minimal data transmission, which suits resource-constrained devices, and low latency for quick message delivery. Additionally, MQTT provides various levels of quality of service, QoS, for reliable message delivery and supports a large number of connected devices, enhancing scalability in extensive IoT networks. In an MQTT architecture, all devices, which mean the clients, will connect to a central MQTT broker. Clients can either publish messages or subscribe to topics to receive messages. When a client publishes a message to a specific topic, the broker forwards this message to all clients subscribed to that topic, enabling efficient communication. In this project, the Pico board connects to the MQTT broker and waits for Adafruit.io to publish an on message to the broker. Once the Pico board receives this message, it activates the LED light. This setup allows for remote control of the LED through the MQTT protocol, enabling seamless communication between devices. Let's begin by setting up Adafruit.io. First, visit the Adafruit.io website and sign in. If you already have an account, simply log in. If not, create a new account. Once logged in, navigate to the Feeds page. Here, we need to create feeds for controlling and monitoring our project. Feeds are used for data storage, so let's set them up accordingly. Next, go to the dashboard section to create components like switches, color pickers, and gauges for control. Remember to link each component to the corresponding feed to ensure data is recorded. Use a value of 1 for on and 0 for off to make control easier. You can also adjust the size and position of the dashboard components to fit your design. After finishing the dashboard design, test it to see if the feed updates when you toggle the switch on and off. Once all settings are configured, we need to link the Pico board to Adafruit IO using our unique key. You can find this key by clicking on the yellow key icon. Next, open a secrets.py file to store your username and AIO key for future use. Make sure to save this secrets.py file in the library folder on your Pico board. After setting up the Adafruit IO dashboard, we can start writing the code. We will use Thonny to write the code. First, ensure that the correct board is connected and that the interpreter is set to CircuitPython. The code begins by importing essential libraries for networking, GPIO control, reading analog signals, and Neopixel LED management. It then attempts to load credentials from a secrets.py file containing the Adafruit IO username and key. If the file is missing, an error is raised. Next, it configures the Ethernet connection by setting up the chip select pin and SPI bus, initializing the WIZnet 5K module with a specific MAC address. The script defines feed URLs for controlling lights, monitoring brightness, enabling rainbow mode, and setting LED colors based on the username from the secrets file. The message function processes incoming MQTT messages to toggle LED states, enable rainbow mode, or update colors. The MQTT client is initialized with the Adafruit IO details and connects to the service, publishing initial LED states. It establishes MQTT callbacks to subscribe to these feeds upon connection and prints a message if the connection is lost. The Neopixel object is created for controlling the LEDs, and an analog input is initialized for reading brightness levels. The main loop continuously processes messages, updating the LEDs based on commands, and runs every 0.5 seconds to maintain responsiveness. Now, let's see the project in action. I'll access the Adafruit IO interface to adjust the LED color and brightness. Watch as the changes update in real time, providing instant feedback. To recap, today we explored how to create a smart LED control system using the W5100S-EVB-Pico2, Adafruit IO, and MQTT. I encourage you to try this project yourself and share your results. For more resources and information, check the links in the description below. Thanks for watching and happy coding!